All right, well, we'll begin. Happy Monday, everybody, and it's week 5. It's February. Time is moving along. We got through January, and we'll see what February brings us. All right. I guess midterm season is starting up. Or you guys already maybe have had midterms already last week. So, and then we have a midterm in this class next week, and I'll talk about that probably Wednesday or Friday, okay? I'll give you heads up on that. Today we're going to look at object-oriented systems in R, and today we'll focus on the S3 system. Okay, so just to introduce object-oriented programming, so some of you may already be familiar with OOP systems. So if you took like C++, they probably covered object-oriented programming, I think. And then in Python, at least if you took Python with me, I covered object-oriented programming in Python. And we also have object-oriented programming in R, okay? Except R's object-oriented programming system is weird, okay? You started off with S3, which was generic function, but it was kind of like loosely structured. They formalized it with S4, and then I guess later on someone said, hey, I like kind of this reference-based object-oriented system, so they added that to R, and that was RC, and then later on they said, let's make it more elegant, so they have R6. So we have 4 different object-oriented programming systems in R, which is probably too many, but anyway, that's what they have, okay? We're going to just focus on 2 of them. S3, which is kind of the, I would say the most important one and forms the backbone of a lot of R functions, but it is weird. S3, I shouldn't say weird. It is different, okay? So the S3 object-oriented system is very different from most other object-oriented systems, and then R6 is probably more similar. It's the encapsulated object-oriented system. And so that's what we'll look at, okay? So the S3 and S4 systems use what's called generic functions. Generic functions look at the object's class and then decide which method to execute. The S3 system is informal. S4 is formal and rigorous, and checks for validity. Okay, the RC reference class and R6 use encapsulated object-oriented programming, and those objects are mutable, and that they can be modified in place and whatnot. And we'll get into all of this. Okay. So the encapsulated OOP systems, that's what's used by a lot of other programming languages like Python and C++ and Java. The way you call methods would be something like object $ method, okay? Or in Python, it's object dot method. So your list name dot sort or something like that, okay? And that kind of shows that the method belongs to the object, okay? And so, one way you can think about encapsulated OOP is I can say, all right, here's a camera, okay? And the camera stores information about itself, like how many pictures have been taken, how much memory is available, whatever, right? The different settings, okay, shutter speed and stuff, okay? And then the camera also has verbs that you can use. Like, so what can the camera do? Okay, well, the camera can shoot a picture. The camera can focus. The camera can record a video, stuff like that, okay? So these would be the methods that belong to the object camera, okay? We have generic function OOP, which is a completely different system of object-oriented programming. And in that case, you have these generic functions, and so the functions, and those functions have methods, okay? So rather than having the camera with the different functions that the camera can do, like shoot a picture and stuff like that, now we have generic functions. Okay, so the objects themselves only contain the data, and then based on what class that object is, when you call a generic function, the appropriate method is going to be chosen based on the object's class. Okay, and so we have what we call polymorphic functions, and that allows a single generic function like print or summary or plot, and those functions behave differently depending on the class of the object that it's called with. So if you wanted to think about generic functions, okay, think of the verb shoot. Okay, so we have the verb shoot, and that verb shoot means different things depending on the object I hand you. So if I say shoot it and I hand you a camera, then shooting it would be, taking a picture with the camera, okay? But if I give you a hockey puck and I say shoot it, then you would set it on the ground and then take a stick and hit it, okay? If I hand you a gun and I say shoot it, okay, you would aim at a target and pull the trigger, okay? So the behavior of that same verb, shoot, will be different depending on the object I hand you, okay? So we have things like that in coding, and if you have a function that behaves differently depending on the object you give it, that's called a polymorphic function, okay? So in R, we have the S3 system, which will use these generic polymorphic functions. There's also S4, and in base R, all object-oriented programming is done via the S3 system. Okay, so here's an example of a polymorphic function, the function summary. The function summary is a polymorphic function, and the way it runs code is going to be different depending on the object you give it. Okay, so we have a data frame diamonds, and it contains, has different information about diamonds. So you can get one of the columns is the carat of the diamond, the size of the diamond, how big it is, and that's a numeric variable. Okay, and then another column in the diamonds data frame or diamonds tibble is cut, and that's going to be like how well was the diamond cut. And that's a categorical variable. So, it's like a ideal cut or very good cut. And when you call summary, the function summary gives you summary information, but the way it executes is different. So the numeric variable, it gives you the 5-number summary plus the mean. So you get the minimum, first quartile, median, mean, third quartile, and the maximum. When you give it a categorical variable, okay, then what it does is it gives you a tally. It forms a table. It tells you how many of each category exist, right? And so we often don't think about this, okay? But just imagine the coding challenge that this would be if I gave you a homework assignment and I said, hey, I want you to write a function that, depending on whether it gets a numeric variable or a categorical variable, it needs to output different information, right? And so you got to kind of think about that, and this just happens all kind of in the background, so the end user, don't have to think about it, right? That's kind of the whole point of object-oriented programming, is that we want to make it easier for the end user to use. And so the end user, when you're doing statistical analysis, you don't want to have to think like, oh, this, I gotta remember the other function name and this other function name. Like, you just want to be able to call summary on certain variables, and you want the summary information. You don't want to have to think about all of this. And so R handles all of that. But if you think about like, oh, what kind of challenge exists in the background for this to make this happen, you can imagine it, there's some work going on there. Okay. So anyway, that's an example of a polymorphic function where you just use the word summary, and depending on what object you give it, it behaves differently, right? Like the verb shoot and depending on the object I hand you, what you do with it is going to be different. Okay. All right, we have classes, we have methods. Classes define the structure of the object. So classes basically define what the object is. Inside the class, it will contain fields or properties that hold the data that's relevant to the object. And then you have methods, which are functions that implement the behavior for that specific class. Okay? In generic function, OOP, the methods belong to the function. In encapsulated OOP, the methods belong to the objects. But that's what we have here. Okay. Another important idea in object-oriented systems is inheritance. Inheritance kind of introduces a hierarchy of classes, and so you often have child classes or subclasses, and they inherit methods from another class, and we call the one that it's inheriting from the parent class or the superclass. Okay, and so when you are looking for a method, and if it's not defined for the child class, then it uses the method that exists, if it exists, for the parent class. And we would say that child inherits from the parent. So we have ordered factors. Ordered factors inherit from regular factors. So regular factors are categorical variables. Ordered factors are ordinal variables. So t-shirt sizes, small, medium, large, extra large. It's categorical, but there's also natural ordering to it. So it's a ordered categorical variable or ordinal variable. Whereas, colors of a car, that's just a categorical variable. There's not a natural ordering. So, you can get a red car, a blue car, silver, gray, black, white. Okay. What order do you put those in? And there's not a natural order to, colors. I guess car colors, that is, but I don't know. You got rainbow color, but I don't know, how do you order, purple, magenta, and pink? It's, like and different shades of it, right? Fuchsia and crimson. Like, how do you put these in order? And it's tricky, right? You have to do it like two-dimensionally, like at the paint wall at Home Depot. But anyway, all right, besides the fact. Okay. We have tibbles. Tibbles are basically in the tidyverse. They're like data frames, but they have those like nice little features. Okay. And so, but tibbles, we want them to behave like data frames if we don't have a method specifically designated for the tibble. So a tibble will inherit from the data frame. Okay. How do we select which method? Oh, wait, here. Before I go on, let me give you your first view quiz answer. Or I haven't given you any, right? Okay, first view quiz answer is D. D as in dog. D as in dog is our first view quiz answer. So how do we select which method to use? Okay, that is known as method dispatch. Okay, and so in R, when we're using generic function OOP, the generic function use method dispatch. Okay, so when you call print on an object, that's a generic function. The print looks at what kind of object it's been given, and then it's going to find the correct method to execute, and that's method dispatch there. Okay, all right. So this is just kind of a slide of the 4 different systems of OOP and R, and again, we're going to just look at S3 and R6 in our class. If you want to learn more about the other ones, you can do that on your own time. Okay, so S3, this is the kind of the simplest but also most widely used system in R, and it is used extensively in like basically everything in base and stats use S3. Okay, and one of the drawbacks of S3 is that it just relies on naming conventions. It's just hoping everybody kind of follows the rules and the conventions, and that's how it works. Okay, I guess some people didn't like that, how informal it was, and so they took S3 and made it more rigorous, that with validity checks to kind of make sure everything's going to work properly, and so that's going to be S4. Basically, S4 puts guardrails on and prevents you from doing things that will cause problems later on. And so if you do something that's going to cause a problem later on, it just gives you an error right away. Versus S3 just lets you do it. It causes problems later on, and then you have to deal with the consequences of that later. S4 just puts guardrails on and says, you're not allowed to do that right away. But you know, it's a little bit of a pain working with S4. We also have a reference class. This implements encapsulated OOP. It's not super elegant, and so they made it more elegant with R6, which is unfortunate that now we have two reference class based object. You know, we have 4 OOP systems, which again is too much, right? But we'll just look at like the 2 of them. Okay, and then we also have base types. Base types in R form the building blocks that we use for all of our objects. Base types, these include all the objects that you're familiar with already. The atomic vectors, not all of them, but atomic vectors, lists, functions, environments, those are all base types. Also other base types that we don't really talk about too much, like names, calls, and promises, but those are also base types. They're not part of any kind of OOP system. You are not able to define new base types yourself, whereas you know, kind of one of the end users can create new classes and stuff as far as the OOP system goes, but you can't just create a new base type if you want. And then you always get the base type when you call type of. When you call type of and it tells you what it is, it'll say it's a list or whatever, you'll get the base type, okay? Internally, base types are C structures, okay? So R is the language R coded up. Part of it is coded up in C, part of it's coded up in Fortran, and part of it's coded up in R itself. And you know, we don't have to think about that. But those underlying C structures, you know, contain the object's contents, but also stuff for like memory management and you know, the type that it has. Now we don't have to worry about memory management, thankfully. If you've ever taken a C++ programming class, like you have to kind of declare these things in these buckets where it's going to store stuff, and there's like memory management stuff that you have to handle, which adds work to you. And you know, it was really important, and it still is really important on a computing efficiency perspective. But now we just kind of say, like, we got these really powerful computers, right? Like your cell phone is more powerful than like any computer that existed, you know, even like 15 years ago. Okay, and so you know, it's impressive, but yeah, we don't have to worry about this anymore. Okay. Anyway, if it's a base type, if you call is.object, you'll get back false. Okay, and pretty much everything that we do with OOP systems is built out of base types. Okay. Now there is something unfortunate, is that the base types are not named consistently, right? So certain things, like you can ask, like, is it a list? And it will say it's a list. Okay. Is it a double? And it'll come back in as double. But unfortunately, things like functions, they're called the function to identify if something's a function or not is.function. But then when you ask type of for the function, you get back closure. So, you know, why isn't it called a function here? I don't know. It's called a closure here, right? And then you have these other functions. They're primitive functions. But then when you ask type of, it comes back and it says it's a built-in rather than primitive. I don't know. Okay, and it feels weird, but mean is a function and sum is a primitive function. Okay, and you know, we don't even bother thinking about. Okay. All right, now I'm going to just skip over that. That's is object, lets you know if something's an object or not. Okay, let's get into the S3 object-oriented system. Okay, this is R's first and oldest and simplest object-oriented system. it uses generic function OOP, and I'll explain kind of how all of that works. Pretty much, most of the objects that you encounter in R are going to be S3 objects, right? Now, unfortunately, we don't have a function to say if it's an S3 object or not. We have is.object that will return true if it's an S3 object, okay? But isObject also returns true if it's an S4 object. So you have to ask, is it an object? And we have a function for is it S4, okay? Is S4 needs to come back false. So you have to say, is it an object and is it not S4? And that will be like an S3 object. Okay. So for example, I can create a data frame, right? So I can make a data frame with two variables. X is the numbers 1 through 10, or integers 1 through 10. Y are going to be the first 10 letters. Is that what? A through J? I don't know. And then here, if I do strings as factors true, then the letters here will become factors. So I can say, is the data frame an object? Data frame is an object. Remember, internally, a data frame is stored as what? A list. Data frame is stored as a list. That's the built-in, that's the base type, okay? But we say it's an S3 object, and we say it's class data.frame. And so if we say, is it an object, that comes back true. It's a data.frame object. Is it an S4 object? It's not. It's an S3 object. What about the column X? Column X, this is a vector. This is atomic vector of integers. Is that an object? It's not. It's just an atomic vector, 1 through 10. Okay. Column Y is a factor. All right. A factor internally is an integer type, but it's a factor, and so factors are S3 objects. Okay. In the S3 system, methods belong to the functions. Okay, and we call these functions generic functions. The methods don't belong to the objects or classes, which is how it works with encapsulated OOP. Here we have functional OOP, which uses generic functions. The methods belong to the functions. Now, you can see the internal code for any function in R by just typing in the name of the function and then not using parentheses. Parentheses calls the function and executes the function, but if you just want to see how the function is defined, you can type in the name of the function, delete off the parentheses, because R tries to automatically insert parentheses, but you just delete the parentheses, and then you'll get the actual definition of the function. And the function mean is just one line, okay? So when you say, hey, what is the definition of the mean function? It says, hey, it's a function. These are the arguments coming in. And then it uses one line of code. Use method, mean, okay? Anytime you see use method, that means it's a generic function, okay? Generic function means tells R inspect whatever object came in, and depending on what object came in, dispatch the correct version or the correct method, the version of the function that we need to use for this object that came in. Okay. So that's how methods are dispatched. Okay. So again, it's kind of the idea that I hand you an object and I say the verb, shoot it. Okay. And depending on the object I hand you, your brain has to think through and say, okay, I'm going to take this object and take a picture with it. Or I'm going to take the object and I'm going to hit it like a hockey puck or something, okay? So, the thought process your brain goes through to say like, okay, what am I going to do with this object? That's method dispatch, right? If I hand you a basketball and I say shoot it, your brain's going to like look around for like a basketball hoop or something that you can throw the basketball into, okay? There's also other generic functions. These are internal generics. Again, all of this is handled kind of in the background, so you don't have to worry about it, but it would be remiss to not include this. And so functions like sum are generic functions, but they are like C functions, and they're built in. So this is an internal generic. Other functions that are generics are like, and again, you don't think about this, but the subsetting function, which is the square bracket, okay, just subset vectors and stuff, that's actually a function, and it's an internal generic function. And so rather than use method, they use dispatch group or dispatcher eval. Anyway, it's just kind of a side note there. The way R uses generic functions is it depends on naming conventions. So things need to be named a certain way, otherwise it gets confused, okay? If you don't name it a certain way, it's not going to know what to do, right? It's kind of like, I don't know, going into someone's kitchen and they have their pantry organized a certain way, and then if you like buy some groceries and you want to be helpful and you put the groceries away, but you didn't know the system and you put it in the wrong spot, and then they say, hey, you know, I want you to find the tomatoes, they're going to be like, I can't find them, right? And you're like, they're in there, but they can't, it's because you didn't follow the system, whatever system that exact worked, right? And so R, it needs you to follow these naming conventions, and if you don't follow the naming conventions, it's going to fail. Like, even if you have everything else defined properly, if it doesn't follow the naming convention, it doesn't know what to do, okay? And again, S4 tries to rectify that by, like, if you don't follow the proper rules, it's going to say, this is going to cause problems. But S3, the regular old system, just says, please follow the naming conventions, because if you don't, I'm not going to know what to do. And the naming convention is generic function dot class name, okay? So it's going to be generic dot class. So if you have objects of the date class and you want to have the mean function, that method needs to be named mean dot date, okay? All right, and so this is the method, the date method, the version of the mean function that works for date class objects, and it's going to be called mean.date, and this is how R finds it. And if it's not named this, it's not going to work, okay? For factors, when you want to print a factor, R finds the function print.factor, okay? So internally, there's a whole bunch of functions. There's print.factor, print.default, print.date, and stuff like that, okay? So a side note is that because the naming convention uses the dot, generic name dot class name, when you name objects yourself, you don't use the dot. Don't use the dot because it can get confusing. Now, this rule was created kind of a little bit later, and we already had functions that use dots and things like that, and it's just, and R now has to be kind of aware of itself. But when you have, like, we have t.test, okay, and t.test conducts like a 2-sample t-test where you calculate the central limit theorem and compares the means of two groups. Now, the way this is written, it looks like it is the t method for test class objects. Okay, it looks like that, but in reality, it is its own function that conducts a 2-sample t-test. Okay, but the way it's written, it looks like the t function, which exists, right, to transpose. We use t to transpose matrices and stuff. It looks like the t method for test class objects. Okay, we also have data.frame, and so the method to print data frames is print.data.frame. But this could be confusing because somebody could say, oh, is there a print.data function or print.data method for class frame? Okay, and we know that's not the case, but the way it's written, it could be confused as that, okay? We know there's data.frame class and there's the print method, but this is a little bit, it's ambiguous, okay? So most modern style guides will say use an underscore rather than the dot to avoid this kind of confusion. Okay, all right, so here's an example of a generic function where I have the function t, I have the matrix. Remember, matrices are produced down column-wise, and I say, hey, make X a matrix with 4 rows, and transpose it. So after I transpose it using T, I get 3 rows and 4 columns. Okay, so that's that. This is the function. Now this same function T, which transposes, I can apply it to a data frame. Okay, so remember, internally, how is a data frame stored? Okay, internally, a data frame is stored as a list of vectors of the same length. Okay, but you know, as the end user, it looks kind of like a little rectangle, and I say, hey, I want to transpose this rectangle. And so I ask R to transpose the data frame, and it does. All right, so rather than having 3 columns ABC, now I have 3 rows ABC and 4 columns. Okay, but again, internally, you know, think about the coding challenge that it would be if I said, hey, I want you to write a function T that's able to handle a matrix, which is stored internally as a vector with dimension attributes, and I also want it to be able to handle data frames, which are internally stored as lists with vectors of the same length. And if I said, you know, I think you guys would be frustrated if I gave you this as a homework assignment, because you'd be like, oh man, I got to think about how to write this function T that's going to behave in a similar, like the output needs to be similar, but internally the code feels different, right? But this is all, again, handled in the background by using method dispatch. And so internally we have 2 methods. We have t.default and t.dataframe, okay? And t.dataframe gets executed when we call it on a data frame. T.default gets executed when we call it on a matrix, all right? So we have these 2 different functions, and R will dispatch the correct version of the function depending on the object that you give it. Now you can see all of the methods that belong to a generic function by calling methods, and you give it the name of the generic function. So if I say methods on mean, we see all of the different methods that exist. So we have mean.date, mean.default, mean.difftime, mean.posixct, I don't know what that is, posixlt, I don't you know, we have all of these different kinds of things, but these are the different kinds of objects that can be passed to the mean function, and it will execute, okay? T.test is also a generic function, and there's 2 things. We got t.test.default, t.test.formula, and this will be this will execute which version. R will figure out which version or method to execute depending on the object you give it. Okay. You can also see all of the methods that can apply to a certain class. So we have class TS for time series objects, and we can call print on a time series. We can call aggregate on a time series, or plot, or cbind, or show, window, you know, all of these things. We can subset a time series using the square bracket. We can use subset in conjunction with assignment, and that's what this means. Meaning you can kind of subset, like you know, subset a vector and then change the value in that specific location. So so those are the methods that belong to a certain class. Okay. All right. Let's talk about kind of creating our own S3 objects and defining classes and methods and things like that. Let me go ahead and give you your second view quiz answer, which is the letter C. C as in cat. C as in cat. Okay, so again, the S3 system is ad hoc, informal. You can just define things on the fly, all right? And so you can do this. You can create new classes by calling the function structure, and inside structure you give it basically a base type, and then you provide the argument class equals whatever. So here I'm creating a list with apple in it, okay, and then I'm going to say class fruit, and we're going to store that object as X, and this is going to create an object of fruit class. Okay, you can also do it by creating an object. So here I say y is a list containing banana, And then after the fact, I just say, hey, the class of y, let's make that to be fruit, okay? And that also works. So both of these will create objects. I have an object x that's of class fruit. I have an object y that's of class fruit. These just like that. I've created a brand new class in R, and this is the fruit class object, okay? Right now, doesn't do much, but we can ask, hey, what is the class of this thing? And R will say it is fruit. So I can say, hey, what is the class of X? And it will say it is fruit. You can also check to see if an object inherits from a certain class. So we can just say, hey, does object X inherit from the fruit class? And you get back true, okay? And again, R has no idea what fruit class is, but we just said, hey, class fruit now exists. And so R says, yeah, that's class fruit, okay? And again, R is just depending on you to kind of follow the naming conventions, okay? But you can name the class whatever you want, okay? Some objects can belong to multiple classes. Remember, there's kind of this hierarchy of classes where you have child classes that inherit from parent classes. So our data set diamonds, okay, is stored in as a Tibble underscore df, which inherits from a Tibble, which inherits from data.frame. Okay, so this is, the Tibble is kind of the tidyverse version of the data frame, and so it inherits from the data frame. Okay, that column $cut, which is a categorical variable, but it's ordered because there's an ordering. It goes from like fair to good, very good, premium, ideal cut. That's an ordered factor. So it inherits from, there's a class ordered, and then ordered is a specific version of factor. So that inherits from factor, okay? So it's kind of like you could create an object that's a square, and square inherits from rectangle, which inherits from parallelogram, which inherits from quadrilateral, which inherits from polygon, which would inherit from shape. Okay, if we wanted to keep going, right? But you can have this thing where it's a subclass or specific version of the superclass that inherits from all of these things. Okay, and so and then the same kind of ideas, right? Like all squares are rectangles, not all rectangles are squares, and it's going to be kind of like all ordered objects are factors, but not all factors are going to be ordered, type of thing. Okay, now when you want to check to see if something inherits or belongs to a certain class, make sure you use inherits and not does the class equal class name. Because remember, when you call class on something, you can get a vector of names, okay? And if you do a vector of names equals something, you'll get a vector of true false values. So if I say, hey, is class of diamonds $cut, is that cut variable a factor? And if I do equals factor, it's going to say ordered and factored, and so I'm going to get a false and a true, okay? We just want to know, hey, is this a factor, okay? And the answer is yes, right? Like, is this thing a rectangle? It is. It's a square and it's a rectangle, but is the question, does this thing count as a rectangle? Yes, it counts as a rectangle, okay? And so you want to use inherits rather than is it equal to rectangle, okay? This is not a requirement, but a lot of S3 objects have what we call a constructor function. A constructor function is a function that creates objects of that class. It's not required. R doesn't put any kind of requirements on classes, right? Like I created objects of fruit class, and I didn't have a constructor function, and I didn't break R. But it's a good idea that if you want to create classes, you create a constructor function. So basically, like if you want to create a factor, there's a function called factor, and this creates factor objects, right? If you want to create a data frame, there's a function called data.frame, and it creates objects of class data frame. So that would be what we call a constructor function. So here I'm going to just make a very simple constructor function, and this is going to be the fruit function, and this is going to create objects of class fruit, takes in an argument x, puts it into a list. Well, first it checks if x is a character, and it's going to give you an error if it's not. And then if it is, it's going to put it in a list, and then it's going to return the object structure list x class is fruit. So I could say z is make a fruit class object out of pineapple, and z is now a list containing pineapple, and it says the attribute class is fruit. And there we go. So that's our constructor function. With S3, you can change the class of an object just because you feel like it, okay? Now, this is not a good idea, but you can do it. So here, just an example, I'm going to create an LM object. So we don't think of LM as a constructor function, but it is. We use LM to create linear models, and what it returns is a big list containing all kinds of information, but it's a LM object, and we can plot that and stuff like that. So LM creates is a constructor for objects of class LM. So if I say, hey, I want you to predict, I don't know, the log of empty gas mileage based on the log of the displacement of the engine, create that creates an LM object. I can print this out like this. Okay, this is how R prints out LM objects. You get the intercept and the slope and so on and so forth. That's how it goes. Now, the class of LM, a class of LM cars is LM. Now, what I can do is I can say, hey, the class is now data frame, okay? We're gonna call this thing a data frame. And R is a little bit confused by this, but R is gonna say, all right, you want me to treat this like a data frame? I'm gonna treat it like a data frame. So when I say print the thing, it tries to print it like a data frame, and it says there's 0 rows, 0 length row names, and it's confusing. It feels like, oh, did we lose all of our information? No, we didn't lose it. Internally, it's still a list, and it still stores all of that information. So you can still ask for the coefficients, and you still have the slope and intercept. But when you try to print it out, it now looks all funny, okay? This is kind of like going to a store and peeling off like the UPC off of one product and sticking it on another, okay? And so at the checkout, it's gonna scan as a different thing, right? This is just plain old stealing and theft, but you know, like as far as like the system goes, you just say, hey, this is not a TV, this is a basketball, okay? You peel off the basketball UPC and you stick it on over the TV UPC, and you check out and it's gonna say, oh, this is a basketball, okay? Again, don't do that, okay? Because it's gonna break R, and you'll get arrested for for stealing, but that's basically what you're doing here, is you're just taking, so internally, it's the R says this is class LM, but we're just saying, hey, like, no, it's class data frame. And R says, okay, it's class data frame. I'm going to try to print it out as data frame. And it feels funny, but you can do that, okay? So this is the warning. While you can change the class of an object, you never should, okay? Because R is not going to protect you from yourself, okay? If you say, hey, this is not whatever LM, it's a data frame, R is going to say okay, and you'll just run into problems later. Okay, but that's what we have. All right, here I'm going to kind of create some methods and just illustrate how we create generic functions and how those methods get dispatched. So I'm going to create a generic function called quotation, and when you want to create a generic function, there's really only one line of code, and it's use method. Okay, use method quotation is going to tell R this is a generic function. When you get an object, try to figure out what class it is, and once you figure out what class it is, find the right method that applies to this class. Okay, so So we just take in, we're going to look for quotation dot whatever class name. So remember, it's generic function name dot class name. So the generic function name is quotation, and when R executes this, it's going to look for quotation dot whatever the class name is. So I'm going to create a method for quotation dot fruit. This is going to be the quotation method for fruit class objects. And this is just going to return a string that says fruits are an important part of a balanced diet. Okay, so here X is a fruit class object. It's a banana fruit class object. We say class of X is fruit, and when I call quotation on X, it finds quotation.fruit, and it returns fruits are an important part of a balanced diet. Okay, now you can also take existing functions and add class-specific methods. Okay, so we have the mean function already in existence. That's a generic function, and I could say, hey, if somebody asks, hey, what is the mean of a fruit? Okay, execute this method, mean.fruit. All right, now this doesn't make any sense, but we're going to say mean.fruit, return the number 5. And so when I say, hey, what's the mean of banana, which is class fruit, it comes back and it says 5. Okay, again, doesn't really make sense to do this in this specific case, but if you want to, you can, right? So you can define new methods for specific classes, in our case, the fruit class, and R is going to just say, all right, when you ask for the mean of a fruit, I'm going to tell you 5. And so we say, hey, what's the mean of a fruit? And it says, just like you asked, it's 5. Okay. If it can't find a specific class name, then it's going to fall back on .default. Okay. So if it's looking for like quotation.fruit and it can't find that, it'll fall back on quotation.default. So almost every generic function will have a something .default, and that's what it's going to fall back on. So here I'm going to define several methods. I got the generic function quotation, and I've got quotation.fruit, quotation.apple, quotation.default. So if it's class fruit, we get fruits are an important part of a balanced diet. If it's class apple, we get an apple a day keeps the doctor away. And then the default object will be let food be thy medicine and medicine be thy food. Okay, so here I've got, I'm going to create a object A. This is going to be class apple and fruit. And so the way method dispatch works is it first searches for quotation.apple, and it finds it. So it says an apple a day keeps the doctor away. Okay, object B belongs to banana and class banana and class fruit. So in method dispatch, it first searches for quotation.banana. We don't have quotation.banana defined. So then it goes to quotation.fruit, and it finds quotation.fruit, and it dispatches that. It says fruits are an important part of a balanced diet. Okay. Here I've got object C. This is class donut. So it searches for quotation.donut. Okay, quotation.donut does not exist, so it and then there's no more classes, so it's going to go quotation.default, and it pulls up the default quotation. Okay, so that's how method dispatch works. Okay, now you can. So again, B is a class banana and class fruit, and so when we call quotation on it, it's going to search for quotation.banana, doesn't find it, and then it finds quotation.fruit, and it gives us that thing. Okay, now you can force R to call the wrong method. So I could say, here's a banana, but treat it like an apple. Give me the apple quotation. Okay, quotation.apple, and it does that, right? It's the same as me handing you a camera and say, shoot it, and then they're about to take a picture, and they say, no. Shoot it like a hockey puck, okay? And that would feel very uncomfortable, but then they would then put the camera on the ground and then try to hit it with a hockey stick, okay? Again, don't do that, but this is what you can do, okay? It's you can force R to call the wrong method. if you don't have a dot default, all right, so if I delete, if I rm quotation dot default, and so that method no longer exists, then you'll get an error. So if I have no default method and I say, give me quotation on class donut, it says no applicable method and there's no default. Okay. I have a few slides here, okay, on a method dispatch self quiz. And so these are a bunch of kind of like, what is it gonna execute, right? So here's a function, here's specific methods, here's a class, this, that, and then you can ask what method is it gonna do. And so this is for you to go on your own time. I've posted a video going over the answers. So like once you go through it, you can kind of go through and review the answers. Let me give you your last, do I need to give you one or two answers? One more. Last answer is A. A as in apple. Third answer is A as in apple. Okay, we will end there and have a great rest of your day. We'll see you Wednesday.